All right, so this is 13.3. Evaluate trig functions of any angle so I'm going to start with number 6. So these say to use the given point on the terminal side of an angle theta in standard position to evaluate the 6 trig functions of theta. So the point that we're given is 5, negative 12. So all we're going to do is we're going to draw a little baby coordinate plane. Doesn't have to be anything spectacular. And we're going to graph this point on here. So where would this point be? Quadrant-wise. Quadrant 4. So it's going to be, it's x being 5, y being 12. So it's going to be somewhere down in here. Okay, so I'm drawing off my triangle from that. So I'm going to have my angle theta in here. Like a really fine point because that just looks like a blob. Let's see if I can change this for a second. A little better, right? Kind of. Okay. So then I know that my x value is 5. So I'm going to put that on there. Y value is negative 12. So then how would I go about finding the other side?
So you're replacing r squared with c squared? Is it equal r squared or c squared?
You can call it either one. I mean, I can't see you. There's a pig. It's like right in my view of like everybody that's on that side. I mean, yes, Pythagorean Theorem is c squared. For the sake of this section, we call it r squared, but whatever you want to call it, I don't care. So x squared plus y squared is equal to r squared, or a squared plus b squared equals c squared. It's whatever you're feeling. So 5 squared plus 12 squared, or negative 12 squared, which obviously the negative is going to go away, is equal to, just for consistency with this section, we'll say r squared. So then, to solve this, r is going to be equal to the square root of 25 plus 144, which is going to be equal to the square root of 169. Does anybody know what that is? 13. Does anybody recognize anything special about this triangle from geometry, possibly?
No.
36
It has.
If I say a 5, 12, 13, is that ringing a bell to anybody?
No.
Pythagorean triple. You heard that before?
What
No.
is that?
Just like a special type of triangle, like a 3, 4, 5 is a Pythagorean triple. 5, 12, 13 is a Pythagorean triple.
How do you know what? How do you know what's?
It's basically just when all the sides are like a perfect square.
Oh, wait,
But there's like certain ones that like pair up to do that.
Still don't
oh,
understand.
Don't worry about it. I just was curious if she talked to you about it.
I get what you're saying, and I probably would have got it last year.
Yeah, that's why I was just wondering. I mean, I know it's obviously been a while since geometry, so it's just, you know, whatever. So then now we're coming over here. We draw our nice little box of what everything's going to be equal to. So then now this is really, this particular part is the same thing as section 1. The only difference is that you're graphing a point and then doing it. It's not just setting up a triangle for you. So what would my sine of theta be?
It would be negative 12 over 13.
12, negative 12 over 13. What's cosine?
5 over 13.
5 over 13. Tangent.
Negative 12 over 5.
Negative 12 over 5. Cosecant.
13 over negative 13.
Negative 13 over 12. Okay, and it doesn't matter if the negative sign goes on top, bottom, or just out front. All means the same thing. Secant.
13 over 5.
13 over 5. Cotangent.
Negative 5 over.
Negative 5 over 12. Awesome. Any questions about that one? Let's see, which one are we doing next? 8 and then 10. Okay, beautiful. All right, number 8. This one we're given the point -6, 9. So where's that one gonna fall?
Oh, and quadrant 2.
2. So -6 for the x, 9 for the y. So something like that. I drew this one a little bigger so I could actually fit my theta in there. Alright, so then we said the x is -6. Y value is 9. So then what is my r square, or my r? Just for consistency with the section, we'll call it that.
I'm getting it. Wait. Yes. Not a bird square. Square root of 117. Didn't say it loud enough.
So
Too bad. Do we have to break it down?
I'm not sure that you can. You can.
Oh, yeah.
But what I'm just going to say is just leave it.
9 and 13. Oh, okay.
Let's just make it, just to make all of our answers be consistent, let's just leave it. Don't pull stuff out of it. If it's something like the square root of 8 or something like that, then sure, I'll take it either way. But with a number that's like obnoxious like this, let's just say consistency, let's just leave it. Okay? So we'll do the square root of 117. I mean, if you like just are so ambitious that you just like are dying to break it down, you can, but yeah, that's what I figured. So all right, so we're gonna do set it up for what we're solving for.
Okay.
So what is my sine of theta gonna be?
It will be 9 root 117 over 117.
Okay, yeah. So just to set this first one up, just as a review. Okay, 9 over the square root of 117. We can't leave that in the bottom, so we're multiplying by the square root of 117 over the square root of 117, which is giving us 9 root 117 over 117. How about cosine?
-6 root 117 over 117.
Okay, -6, and then because we're going to have a square root on the bottom, we can go ahead and just set it up as -6 root 117 over 117. Tangent.
-3 over 2.
Okay, yeah, so make sure, okay, it would originally be -9 over 6. Make sure you reduce it down to -3 over 2.
Do we have to write the 9 over 6, or if we know it, can we just write it?
No, you can just write the simplified one. And then, like, Peyton, you said it was 9 and 13 that makes 117. Is that what you said? So if you had reduced, like, the sign up here to be the square root of 117 over 13 or something like that, that's fine. But I'm also okay with you leaving these really big ones like that. So just if it's something, 9 over 6, like, that should be very obvious that we can take something out of it,
Yeah.
simplify it. But again, I'm less stressed about that. If you can set it up, that's what the concern is for trig. Cosecant.
Oh, root 117 over 9.
Secant.
Root 117 over 6. One negative.
Okay, negative root 117 over 6. Cotangent.
Negative 2 over 3.
Negative 2 over 3. All right, we'll do one more of this type. Number 10, the 0.5 and negative square root of 11. So I should close that off. Literally forgot those were over there. I just bought them like 2 days ago. I should know that. Yeah. All right, so where's this one going to be?
Quadrant 4.
Quadrant 4. So it's going to be down in here. So my theta is there. So x is 5. Y is negative square root of 11. That's just annoying. The square root, not whatever's going on out there. I mean, that's kind of annoying too, but. So we're going to find the other side. So r squared is equal to 5 squared plus, since I know the negative sign's going away, I just drop it initially. Square root of 11 squared. So then r is equal to the square root of 25 plus, that's just going to be 11. So is that 36?
That's it.
So r is equal to 6. That was kind of nice. So my hypotenuse is 6. Then I can set up
I always forget that when you square root, it just becomes,
That number.
yeah. I was like,
It's easier.
That's kind of weird to like think about, like, oh, I just gotta get rid of it.
Just get rid of that, yeah.
Just get rid of the box around it.
Seems
Do
like it
what's
should be more
family.
complicated.
Okay. Sine is negative square root 11 over 6. Then cosine is 5 over 6. Tangent is negative square root of 11 over 5. Cosecant is 6 square root negative 6 square root 11 over 11. Secant is 6 over 5. Cotangent is negative 5 square root 11 over 11.
Whoa, how in the... Just like erased on its own. That was weird. Okay, let's see. We've only got like 10 minutes left. So what are we gonna do here? Where are we at?
What thing?
What? You didn't want it.
It just has a singular.
Okay, let's look at 12 and then maybe one more and then we'll stop for today. So, the next one say to evaluate the 6 trig functions of theta, and these are for quadrantal angles, okay? So these are the ones that are in increments of pi over 2s So 12, it tells us that theta is equal to 0 degrees. So I'm still going to set up a little baby graph here.
They're still ugly.
Oh.
Even when they're big.
That's weird.
It's true.
All right, so 0 degrees is where?
In the middle.
The right side
The right side, okay, the x-axis.
Oh.
So it's right there. I tried to pick a color that would be like bright and obvious, but kind of worked. All right. So, what are the coordinates of that point?
1, 0.
1, 0. Okay, and then I'm just going to refresh that sine is equal to y over r, and cosine is x over r, and tangent is y over x. Okay. So we want to find all 6 trig functions of this theta of 0 degrees. Okay. So these really aren't actually bad. They just, well, they look kind of like they're going to be bad, but they're actually really easy. Cosine of theta, tangent theta. Now with something like this, what does my r value have to be?
1.
1, because we still can do it the same way. So we get r squared is equal to x squared plus y squared. So we would have r is equal to the square root of 1 squared plus 0 squared. So that's just going to be r is equal to 1. And that's going to be consistent for all of these, the quadrantal ones. So what then would my sine of theta be?
Your sine theta would then be 0 over 1, which is just 1. Or it's just 0.
0.
Yeah. Right. I was getting confused.
What would my cosine of theta be?
1 over 1.
1 over 1, just 1. Tangent,
1 over, 0 over 1.
0 over 1. It's just 0. So then cosecant is undefined because 1 over 0 can't divide by 0 or Cookie Monster has no friends. So it's
You don't get that?
undefined. You've never asked Siri what 0 divided by 0 is?
You have no friends.
Oh, yeah, it's like, we have no.
And you have no friends.
You have no cookies and you have no friends. And Cookie Monster is sad. Alright, secant,
1.
it's just 1. 1 over 1, just 1. Cotangent,
Undefined.
okay, 1 over 0, so it is undefined. Okay, and you're completely fine to just write undefined. I'm just writing the reasoning here for it so that we see it. I'm going to do one more example here in radians for you. That's not one that's listed in your book. Theta is 5 pi over 2. Now, do we know where 5 pi over 2 is just on the unit circle itself?
It's like the
Yes.
next 90
What?
degrees. Like you have to go all the way around and then.
Yeah.
Okay, so we're going to go around. So I'm just going to count pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Okay, well, thank you for making a circle. Just gonna, there. Okay, so it's going to be the same as pi over 2. So it's going straight up. All right, so what are my xy coordinates of this one?
Oh, it's
0, 1. Okay, r is still going to be 1. So I'm going to find my 6 trig functions of this. So what is sine of theta?
Sine would be 1 over 1, so 1. Yeah.
1 over 1, so that's just going to be 1.
Cosine would be 0.
Yeah, because it would be 0 over 1, so it would be 0.
And then tangent would be undefined.
Tangent is undefined. 1 divided by 0.
Cosecant would be 1.
Cosecant is 1, still 1 over 1.
Secant is undefined.
So you're going to have 0 over 1.
And
Sorry, 1 over 0.
And cotangent is 0.
And then for cotangent, you're going to have 0 over 1, which is going to be 0.
It's easy, but it's not very exciting.
Yeah, I know. Though they tend to cause a lot of issues.
Really?
So, anyways, we're going to stop there. Tomorrow we'll do reference angles and then evaluating functions without using the calculator, which is more of just looking at the unit circle and doing stuff. But we'll actually look at some that have negative angles and how to read it off the unit circle. So,
Each of these sections